Okay, so we're on lesson 3, relating roots and intercepts of radical functions. You ready? What we're going to do is we're going to solve algebraically. Okay, when we look at the word solving, you've done this before. You've solved for a variable before, right? So when we solve for a variable, what we're going to do is we're going to isolate the variable. Okay. So how do we isolate the variable x in here? Isolate means having it alone. Okay. By itself. So, there we go. Any thoughts on how we could do that? Yeah. Yeah. Okay, so I'm gonna combine your thoughts and then, okay. Ready? Yeah. Take 3 to the other side. So I'm gonna do what you say. So x plus 5 equals to 3. Take 3 to the other side of the equation, and that will give us a positive 3. And then the next part you said was get rid of the radical. Well, how do we get the square root out? Yeah, square the other, each side. So we're going to square. So that gets rid of the root, the radical. So it's going to be x plus 5 equals to 3 squared is 9. Okay, now what's next? Bring the 5 to the other side. So x equals to 9 minus 5. So x equals to 4. Okay, so what we have to do before we state that 4 is the final answer, what we have to do first is to check or verify our solution. Okay, we have to verify the solution. In this case, there's only one solution, x equals to 4. Then how do you verify? We have to go with the left side, work it out, and then we have the right side, work it out. Okay? What does the left side look like? The left side looks like this. Square root of x plus 5 minus 3. That's the left side of the equation. What's the right side of the equation? 0. Okay? So the left side equal, we have to verify to see if they match on the right side. So we said here, x we found out to be 4. So we're going to substitute 4 into this equation, or not into expression. So it's going to be 4 plus 5, square root of that, minus 3. Okay. And we all know orders of operation, right? Working from inside out. So 4 plus 5 is 9. So square root of 9 minus 3. And then square root of 9 is 3 minus 3. And we know that's equal to 0. So that shows that it's 0 is equal to 0. Yeah.
You can also set the right side to 3 and then 4 plus 5.
Yeah, you could do that. Yeah, it would still maintain the thing. Yeah, absolutely. Yeah, and then you only have that one radical to work out. Okay. So we solved it. We verified that it is true. So we gotta state our final solution. So therefore, I'm going to do this because some people got upset that I don't use a shorthand of therefore. So therefore, the 3 dots, x equals to 4 is the solution. Yeah, that's the word of the day, technical. Okay. Is that okay? Yeah? Okay. So this part here is the solving algebraically. This is solving algebraically. That means we work it out without graphing, we're just solving it using algebra. Yeah. Now letter B, what we're gonna do. Can I ask you something? Identify the x-intercept of the graph y equals to square root of 5 minus 3. What is the x-intercept of the graph? 4. Okay. So x-intercept is 4. Okay. What do you know about the x-intercept? What's so special about the x-intercept?
It's positive. It's an invariant.
Oh yeah, it will be the invariant point. Yes, you're absolutely technically correct. Yes, in this case. Yeah, but what's so special about the x-intercepts in general?
If you know the x, you know the y.
Then what's the y?
0.
0. Excellent. So we know when something is an x-intercept, it means it touches or crosses the x-axis. So also the y value is 0 for x-intercept, correct? Right? At the x-intercept, y is 0. So when we look at this one in here, if we substituted 0 for y, right? Hold on. I'm gonna rewrite it because I want to make sure that it's clear and I don't have arrows going everywhere. So this is what it looks like. Y is equals to the square root of x plus 5 minus 3. So if we wanted to find the x-intercept of the graph, we're going to set y equals to 0. So 0 is equals to the square root of x plus 5 minus 3. And we already solved this one, right? We already solved that one. And that gives us x being equal to 4. So what does that mean? So x-intercept is equals to 4. Now, putting it all together, okay, describe the relationship between the x-intercept of the graph and the roots of the equation. The roots of the equation is the solution to the equation. So what are they? So we know that the root of the equation is the same as the x-intercept of the graph, right? Okay. So they are the same. So what we could do is we could always find the x-intercept by figuring out the roots of the equation. So i.e., we could find the x-intercept by solving the root of the equation.
You would know the x-intercept so you don't have the root, right? You would know it's the x-intercept even though you have the root.
Yeah, you would know.
Why
Yeah,
do you do it?
exactly. Is that okay?
Solving the
Oh, sorry. You need it? Okay. Yeah, okay.
cost of the equation.
Oh, this is the root of the equation. Root. Yes? So far so good. Okay. Now this one here is going to be a big question. So what we're going to do is we're going to solve this. We're going to solve this algebraically, and we can also solve it by graphically. Okay. Let's solve it algebraically first. So how do we solve this algebra? Any thoughts on how can we do? We're going to square both sides. Everybody agree? So we can go, I'm going to start here because it's going to be a long process. Thank you. And just leave it there. Perfect. Okay, so that's the original one equation. So we're going to, you said to get rid of the radical, we're going to take a square root, or square, get rid of the square root. So what does that give you? It's going to be x plus 5, right? What would this give us? X plus 3 times x plus 3. So what would that give us? It's going to x squared plus 6x plus 9. Okay? Because it's going to be x plus 3 times x plus 3. Is everybody okay with that? Okay, so that, how? Yeah, that's a good question. Why, right? So, okay, I'm just gonna focus on this one here. If you're not sure what that is, x plus 3 squared means x plus 3 times x plus 3. So x times x will give us x squared. X times 3? 3x. 3 times x is 3x. 3 times 3 is 9. So that's, collect like terms, x squared plus 6x plus 9. Yeah? So please be careful. Okay? When you look at that one, don't think it's going to be x squared plus 9. Now when you get to that part, we're going to end up with a quadratic equation. So how do we solve for quadratic equation? Bring everything to the other side. X squared plus 6x plus 9. The x goes to the other side, so minus x. The 5 goes to the other side, so it's minus 5. So what does that give us? X squared plus 5x plus 4. Okay. Oh. So how do we solve this one? Yeah. When we look at, this is a grade 11 topic. This is a grade 11 pre-calc topic where solving a quadratic equation. You can solve a quadratic equation by factoring. If it's easy to factor, let's factor. What's the other way? Completing of squares. I'm not a fan of that, just to let you know. And then what's the other one? Quadratic formula. Okay? So the one that we're going to take a look is, see if this is factorable, we'll do factoring. So is this factorable? Yeah, it is factorable. So what does it factor to? X plus 1 times x plus 4. Okay? X plus 1 times x plus 4. Now, we have to use the zero product property. What does that mean? You've done it last year. It's called the zero product property. Oh, are you telling me already the answer? Yeah. Zero product property means that anything that's multiplied by 0 is 0, right? So anything that's multiplied by 0 is 0. So this number times this number. So what would be the x value that will make this factor 0? -1. So you have a first solution, so therefore x equals to -1. And what will make this and x -4, okay? Yes? Okay, grade 11 topic. So we have, it looks like we possibly have two solutions. So what we're gonna do is we're gonna verify it before we finally state our answer. So, verify. We're gonna verify x equals to -1 first, see what that looks like. Remember, the left side has to equal the right side. Okay? So the left side is gonna be square root of -1 plus 5, and then this is gonna be -1 plus 3. Do you see it's gonna happen? Do you see that this is gonna be right away true? So square root of -1 plus 5, that's gonna be square root of 4. Square root of 4 is 2. Then over here, -1 plus 3 is 2. So left side equals the right side. So what does that mean? X equals to -1 is a solution. Okay? Now we're gonna verify x equals to the other one, -4. So you got the left side and then the right side. What does the left side look like? Square root of -4 plus 5. Okay, that's gonna give us square root of 1, and square root of 1 is 1. Yeah, that one's pretty good. What about the right side? -4 plus 3, that's gonna give us a -1. Uh-oh.
No,
We have a problem here. We have a problem here because the left side is not equal to the right side. So what can we say? Yeah. So x equals to -4 is not the solution. So the only solution in this case, okay, even though it says here we have two solutions, only this one is our solution. Only solution, not this one. Okay, because when we verified it, okay. Now this is called an. Do you know what it's called? Do you remember what it's called? Yeah, extraneous solution. Okay, solution algebraically, but when we verified it, it's not. Extraneous solution. Okay, is that good? Okay, now we solved it algebraically. Now we're going to solve it graphically. Okay, what we're going to do is that what I'm going to do is I'm going to separate these two separate functions. Okay, two separate functions. Okay. Do you remember in grade 11 you talked about systems of equations? Systems of equations, or maybe grade 10 and grade 11 too. You did systems of equations. So systems of equation is when you have two functions, you graph them, and the point of intersection is the solution. Does that Sound familiar? Systems of equation. You graph two functions and the point of intersection is the solution. So we're gonna do this graphically, okay? What does that look like? Let's start with this one here. How do we graph this one? How do we graph this one? Okay, here's what we're gonna do. We're gonna first graph x plus 5. Do it with a pencil first. Okay, we're gonna do it with a pencil. How do you graph x plus 5?
You just put point on 5.
Yeah, it's gonna be a straight line. It's a linear function, right? Y-intercept is 5. Okay, earlier there was some kind of discussion about that one. So y-intercept is 5, and then because it's x, the slope here is 1. So that means it's gonna be, the slope is 1, rise over run. Okay, you can go up 1, right 1, or down 1, left 1. Yes? Are you okay with that? Linear function. So, okay, so linear function looks like this. So, here's a way to figure out the graph of the square root of x plus 5. We graph this one first, just like what you did with your activity this morning. You graph the linear function first, under the function under the radical, and then now apply the square root to that. Okay? Now because we want the square root of, okay, we can disregard the negative f of x, negative y value, so that's our one of the invariant points right there. And where's the other invariant point? So invariant point when y is 0 and y is 1. So here's the other invariant point. Okay, and then here this is, the y is 2, so the square root of 2 would be 1 point something. Square root of 3, because remember we're taking the square root of y. Square root of 3, no. Square root of 4 is positive 2, so we can use those nice points. So the graph, there's a little bubble there, and then this is what your graph looks like. Okay, so this is like the faster way. Oh, that's a good one. Okay, good one. It's probably a little bit challenging to hear because of the drilling in the. Okay, first, okay, we're gonna graph this part. So to do that, we're first gonna graph the inside function. So the graph of x plus 5 is a linear, right? So y-intercept at 5, slope of 1. So that means y-intercept of 5, and then slope of 1. So up 1, right 1.
You did 1 of the x.
That's a slope. Are you okay, Ruda? Yeah. So here, y-intercept for x plus 5 function, y-intercept is 5, slope is 1, right? Slope is rise over run. You can't forget those things, because when you get to calculus, is that, yeah.
This is the second, so it's x plus 5. Why is it square root of x plus 5 and then it goes to go down a bit? You have y is square root of x plus 5 and then y is x plus 3.
Okay, I think that's when you stepped out for a bit.
I did, yes.
Yeah. So what we're doing is we're splitting it up into two different functions,
Okay.
right? The systems of equation. This is your first function, and then this is the second function. So, going back, is that okay?
Yeah.
Okay. Yeah, you're probably thinking, is it supposed to be x plus 3? No, it's x plus 5. So y-intercept is 5, the slope is 1. So up 1, right 1. Rise over run. So that's this one here. Now, this is not x plus 5, it's the square root of x plus 5. So this part here is the y value. We're taking the square root of the y value. So here, this was the extension this way. We said we cannot take the square root of negative value, right? So we're going to erase that piece. And then we're starting from a non-negative y value. So this is a non-negative y value. This is the y's. This is a non-negative y value. What else?
Why are we using 5 and minus 5?
Start off with this one. Okay, start off with this. If this is our function, right? This is our graph. This is going to be negative 5, 0. Yes? Negative 5, 0. That's this point here. The other point on this graph is negative 4, 1. That's this point here. You see that? Now this part here is negative 3, 2. What's the other one? Negative 2, 3. Another one. Negative 1, 4. Another one. 0, 5. Another one. 1, 6. So in this particular case, this is the f of x, which is x plus 5. And then this is the square root of x plus 5. Okay. So the square root of f of x is what? Square root of f of x is 0. Yeah. Square root of f of x. What's this one? 1. This one is? Root of 2. This one? Root of 3. This one? 2. Okay. So the one that you're graphing or plotting would be this and this. Now, what I'm doing there, that drilling the thing is really, okay. So, look at it first for a second. What did I do? Okay, just like what we had at the beginning, we started off with the line, right? We started off with the line. So what I'm going to do is I'm going to start off with the line x plus 5. That's the one that I entered. I've drawn here. Okay, yeah, so there's your line. That's your function. What did we do? Yesterday, we disregarded this part here, right? Because we cannot take the square root of a negative value. All of these are negative y values, so get rid of that one. So starting in here. So this is remember here, we're taking the square root of the y values. What's the square root of a 0? 0, right? What's the square, the y value here is 1. So what's the square root of 1? 1. Very good. And then here, square root of 2 would be 1.4. Okay. Okay, I don't like that. I'm gonna go here. What's the square root of 3? It's not gonna be a nice number either. And then here, the y is 4. Okay, remember we're squaring, taking the square root of a y value. 4. It's 2. So these are the 3 points that are really nice. So this is your root of the function. Okay? Those are the points. The negative 5, 0, this one. The negative 4, 1, that's this one. And then the other one is negative 1, 2. Negative 1, 2. Do you see that? Yeah?
Those are my invariants, right? Or no?
Oh, these two are.
Those two,
Okay.
yeah.
So this part here, I could erase this because this is just a way to help me graph my radical function. Okay. So that's just this piece. Okay. Of course, there's a bubble there, and then onwards. Okay. So that's graphing that part. Well, how do we graph the other function? Because remember, we split it up into 2 different functions. How do we graph x plus 3? Okay, you're an expert in this one. Y-intercept is 3, yeah. Yeah, so slope of 1, so you go up 1, right 1. Up 1, right 1. Okay. Okay, so the question is, what is the x value where they intersect? Where did they intersect? At x being negative 1. At negative 1. So that's that one. So the solution would be x equals to negative 1. So here, the point of intersection now what about this one? Remember we said earlier negative 4 is not our solution?
Yeah.
Why is it not our solution? Do they intersect here at all? No. So that's why here it fails in here, and this is the visual part of that it does not intersect. What does this remind you of? What does this? Yeah, okay, yeah, that kind of gives us a quadratic look, except that instead of, quadratic last year when you were learning about, maybe last year, you do that way, right? And if it's a quadratic, it would have gone this way, right?
Yeah.
And if it had gone that way, look, that could have been a point of intersection. But remember, it's not defined here because it's not quadratic. It's a square root of the function. Yeah.
So what would you rather see? X is greater than -5 to infinity, or x is greater than -5 to x is real numbers?
It they ask us anything about domain and range?
No, but I'm trying to.
Okay. Don't put that in. If this is a question, don't put extra. Because on the test and on the exam, anything extra, it shows that I'm not sure when to stop. Should I stop here or should I not? So that shows that maybe not. Somebody's not sure. Okay? So don't put extra, don't put too much, and don't put too less. So, yeah.
The point of intersection. We describe in coordinate form, -1, 2.
No, you'll just say, because there is no y in this equation. There is no, that's a good question. Your classmate here says, can I put -1, 2? Okay, that's a good question. That is a very good question. I'm gonna not write it down, but I'm gonna show you why no. Because if we say the solution is -1, 2, this is your x and then this is your y. The original question looks like this. Right? There is no y in this equation, so we should only be stating the x. So x equals to -1. Good question. Very good. Okay, how's that one? This algebraically solving is much better than solving graphically. Okay, solving graphically, but graphically is important so that we can see, because we want to be able to see what that means. What are we solving here? What does that look like? So if you look at that, hey, that's a radical. That's a graph that's looking like this, and then this is a graph looking like that. Where do they intersect? And that's the point of intersection, and that is the solution. Okay, just like anything else, practice make things perfect and better. Give these questions a try. We have quite a bit of time. So page 93 from your book, and I think everybody got a book, as far as I know. Question 9. And it says here, add solve algebraically. So solving it algebraically instead of graphically. Okay, so let's take a look at page 93. Okay, so page 93, question 9, that's it. Solve algebraically. If you wanna know what the quadratic formula is, I'm gonna write it, well, it's over here. If you don't remember what the quadratic formula is, that's what it is. If it's not factorable, then use this one. Okay, does that look familiar to you? Yeah. Okay, it's only 4 questions. We only got 20 minutes, so give those questions a try. I think I'm going to stop right there.
if it's okay if I go.
That's okay.
I've already looked ahead, so.
Oh, you're working, oh, okay.
I have a question. I was told to ask you if I can get, so I'm wondering if I can get the free cal 10 book and 11 book. I know that you're probably short of them. I don't know. So I was told to ask you, answer. Now, are you able to